Hello, welcome back to Ali Maths. In this video, I'm going to be going through some of the more basic and fundamental circle theorems, the properties they bring and how to prove them. This will provide a perfect base for some of the slightly more advanced circle theorems which we will look at in future videos. Remember to like and share this video, subscribe to the Ali Maths channel, and leave a comment with any feedback or requests for topics or questions. A quick disclaimer before we begin. You won't need to learn all of these proofs if you're just sitting your Maths GCSE for most major boards like Edexcel or AQA, since you're not often asked to prove basic ones and never more advanced theorems. However, if you're doing the level 2 further Maths GCSE, you will need to learn all the proofs and will be asked them in the exam. The first circle theorem that we're going to prove tells us that a triangle formed by two radii is isosceles. This means that in our diagram, the triangle AOB is an isosceles triangle. This is actually quite a simple theorem to prove, and it all rests on the definition of a circle's radius. All radii of a given circle are equal, which means that OA and OB in our circle have the same length. An isosceles triangle is a triangle which has two equal sides, and because OA equals OB, we know that this triangle is isosceles, hence proving our theorem. This can have very useful applications within a question, because this would tell us the angle OAB and angle OBA are equal. The second circle theorem states that a diameter bisects a chord at right angles. Our diameter can be seen here, through our chord AC, and according to our circle theorem there is a right angle at angle OBC. Additionally, our chord AC should be split into two equal parts, AB and BC. To prove this theorem, we first need to draw a few construction lines. Here we draw in the construction lines OC and OA to form two triangles. Because this diameter is perpendicular to chord AC, angle ABO is also a right angle. In the first theorem, we proved that a triangle formed by two radii is isosceles. Here in this diagram, we formed a triangle using two radii, which means that it's isosceles. Therefore, its base angles are equal. The two triangles OAB and OCB both share two angles which are equal, x and two right angles. They both have two equal sides, both radii of the circle, and have one shared side. Therefore, we can say that these two triangles OAB and OCB are congruent. Two congruent triangles are completely identical, so all of the sides in one are equal to the corresponding sides in the other. Here, this means that AB equals BC, so we've proven our original theorem. This notation at the end, a square and the letters QED, is something which is used by mathematicians to demonstrate that they've proven something. QED is the Latin abbreviation quod erat demonstrandum, meaning which was to be demonstrated, a fancy way of saying that they've proved a theorem, and is used as a sort of mic drop by mathematicians. So if you want to flex your knowledge to the examiner while you're doing an exam, here's how to do it. The third circle theorem states that a tangent to a circle meets its radius at a right angle. A tangent is a line which only touches the circumference at one point, without being inside or outside of the circle. The circle theorem tells us that, in our diagram, this tangent is at a right angle to the radius OA. You can prove this theorem without needing to draw any construction lines, simply by thinking of this tangent as a chord which has been extended and brought out of the circle. We've just proved that a chord is bisected at right angles by a diameter or radius. Imagine that we moved or extended this chord back out of the circle, so that it becomes a tangent. The angle between the radius and this line stays at 90 degrees. In an exam situation, this is not a theorem which you would be asked to prove. The final circle theorem of this video states that the angle in a semicircle is a right angle, also known as Thales' theorem, after the Greek mathematician. The conditions for an angle in a semicircle are particular. The angle must be formed by two lines which extend from opposite ends of the circumference on the diameter. To prove this theorem, we must draw some construction lines and introduce some variable notation for angles. Like we proved in the first theorem, a triangle formed by two radii is isosceles, and this can be seen in two cases here with triangles AOB and COB. Because all radii of a circle are equal, OA is equal to OB, and OB is equal to OC. The base angles of an isosceles triangle are equal. Therefore here, BAO and ABO are both equal, and OCB and OBC are both equal. Now we've marked those two angles in, and we should remember that the angles in the triangle add to 180 degrees. Looking at our bigger triangle, ABC, we can see that it's composed of the angles X, X, Y, and Y. This can be rewritten as 2x plus 2y equals 180. We can divide both sides of the equation by 2 to get x plus y equals 90. We can see that the angle ABC is equal to x plus y. As we've just seen, x plus y is equal to 90 degrees. Therefore, we've proven our original statement. Angle ABC is 90 degrees or a right angle. This concludes my first video on circle theorems, with the remaining theorems covered in 2 other videos. Make sure to leave a like and comment on this video, and subscribe with post notifications turned on. Thank you so much for watching.